Hello, and welcome to our presentation today about neuromorphic chips. Firstly, we would like to introduce of all the members for my group. My name is Ruizhe, and we also have Chuyang and Chengwen. Hopefully, towards the end of this presentation, you will get a rough understanding of what a neuromorphic chip is and how it will work. So there are four main topics we would like to talk about, which are what is a neuromorphic chip, why in the real world we need a neuromorphic chip, how does it work, followed with some current existing examples of neuromorphic chips, and lastly, how it will be developed in the future. So let us first talk a little bit on what a neuromorphic chip is. The concept of this neuromorphic network was first introduced in the 1980s by Carver Mead. Later, this concept got researched by different universities and companies. As the name suggests, the neuromorphic network applies to the concept of how a human brain works. The aim is to create a device that can learn, retain information, and then make logical assumptions that a human brain can. From research shows, a neuromorphic chip may not be as flexible as the current von Neumann architecture, but it consumes way less energy for the same amount of workload. Despite the fact that the von Neumann architecture can continuously process input data, it has limitations in power consuming, pattern recognitions, real-time recognitions, and judgment. Although the structure has excellent performances in running digital calculations or writing programs accurately, it has limited capabilities in processing and understanding images and sounds. Moreover, the neuromorphic chip have a strong ability of damage recovery, which means even with faulty components, it still can produce appropriate output. While the lifespan grows, the technology becomes smarter and enhances itself throughout the self-learning process. So why do we need a neuromorphic chip? The current neural networks cannot learn about new data and need to be restrained from scratch each time. The reality is that neural networks need to be able to self-assess the need for restraining and the fact that they do know certain things. Also, the AI model, which is functioned by neuromorphic chip, will be able to adjust each of the artificial neurons as it reviews more and more data. Gradually, it becomes more accurate at the specific tasks it has been designed for, such as detecting cancer in slides or flagging fraudulent bank transactions. Now I'm going to pass on to Chu, and he's going to discuss about some real-world examples.
Before we jump to what we know about real instance about the neuromorphic chips, we would also like to know how does neuromorphic chip work. The chip introduced a level of parallelism that does not exist in today's hardware, including GPUs and most AI accelerators. Neuromorphic chips are also packed with artificial neurons and artificial snaps that mimic the activity spikes that occur within the human brain. Neuromorphic systems perform on-chip processing simultaneously while use event-driven processing models to address computing problems. Let's take a look first at the neuromorphic chips called Loki, which is designed by Intel Labs. In the last decades, Research and development efforts are beginning to produce tangible results. There are several experimental examples of neuromorphic chip products which have been shared with public organizations. Two of the most prominent products would be Logi and True North. Logi is a research chip that uses spiky neural network architecture. Specifically, it is a 60 millimeters chip fabricated in Intel's 14 nanometers process that advances the state-of-the-art modeling of spiky neural networks in silicon. Logi features a many-core mesh comprising 128 neuromorphic cores, 3 embedded times 86 processor cores, and off-chip communication interfaces that hierarchically extend the mesh in four-planar direction to other chips. The chip is designed with a high level of configurability, along with cores that can be optimized for specific tasks. Moreover, Logi can solve least absolute shrinkage and selection operator optimization problems, with over 3 orders of magnitude superior energy delay product compared to conventional solvers running on a CPU ISO process voltage area. It is also noticed that more than 80 members of Intel's neuromorphic community, such as universities, government labs, neuromorphic startup companies, and Fortune 500 firms are now experimenting with Logi. On the other hand, True North, designed by IBM, has also featured quite a few remarkable qualities. The chip is designed particularly suited to high-speed and low-energy image processing and classification tasks. It contains 1 million spiky neurons and 256 million low-precision snaps, which achieves this efficiency with a spiky neural network. However, software for True North requires a very different programming model than most traditional CPUs or graphics processing units. Unlike von Neumann architectures, which use addressable main memories for both data and machine instructions, the highly distributed True North architecture does not have an addressable central memory from which to fetch, decode, and execute instructions for its neurons. Now I'm going to pass to my teammate Chengwen. He's going to continue to talk about the new model.
In the next 3 to 5 years, neuromorphic chips are likely to have a significant impact on energy device and IoT systems, and change information that doesn't necessarily run a single algorithms or while conversing enriched. Currently, it is notable that Tsinghua University used hybrid story to develop artificial visual sensors neurons that symbols witness for future research on bringing heuristical conclusions. Future models let us imagine connecting the neuromorphic device to a car's camera. The systems can identify the traffic lights and various targets on the road, and respond in time without the need to connect to the internet. We hope to use the no images register to process these tasks located in real time. In conclusion, neurophysical technologies remains in its infancy. They are not commercial products or killer applications, yet innovators in its devices rapidly and radically. So the neuromorphic chips is still an experimental product in the last few years. Software and hardware matching it will appear one after another. For instance, neuromorphic chips are also expected to be applied to various IT technologies, such as facial recognition, vocal recognition, robots, drones, self-driving cars, and wearable devices. These technologies are the core technologies of the futures and will play an important role in the first industrial revolutions. Neuromorphic technologies will bring us more complex technologies, such as AI doctors can accurately diagnose the patients, self-driving cars without human interventions, and so on. Neuromorphic chips have a high utilization rates and unlimited growth propagation.
Neuromorphic computing aims to open up an entirely new and unexplored areas of computing. It could also allow people to do things with computers that we couldn't have imagined in the past at unlimited growth potential. And that's all. Thank you guys very much for listening. If you guys have any questions, we would like to take them noted.